let's proceed for today's session. Okay, so first we are going to load our Assam state boundary. Okay, so the idea here is to use our polygon, polyline and point features to get some information on how far two points are, okay, and where the polygon is intersecting with the polyline, okay, and all these things. We will see the story, if we will try to build a story with the data. Okay, so this is going to be our study area. Okay, Assam admin boundary. So admin boundary contains all the districts. So there are some less district because this data is little bit older. I think now in 2023 some more districts are added to Assam state. Okay, so please ignore that fact for now. Okay, so let's say we have just 24 districts here. Okay, right. So next we want, first what we will do, we will reproject it. Okay, because now we are doing some processing, we will do some calculations, we will try to reproject it. Okay, so how we can do that? You will go to processing, you will go to toolbox. Okay, let's close this. Yeah, you will go to toolbox. So type here reproject. Okay, and in vector general you will find reproject layer, right? So double click on reproject and select the layer that you want to reproject. First let's do Assam state boundary. Okay, and we know that Assam falls in 46 north zone of UTM. Okay, and let's see, it is again showing you the area. Okay, right, so click on run. Right, so we have to reproject another layer. Okay, we have to reproject this. So again what you will do, click on this and in processing toolbox, in processing go to toolbox, click on toolbox, and after clicking you will get this window. Okay, toolbox, it's gone. Again click on toolbox. All right, next you will find the list of processing that you can perform in QGIS. Okay, in this type reproject. Okay, right. So we have recently used reproject layer. So double click on the reproject layer. Okay, and we want to go with Assam admin boundary this time. Okay, and then go to the UTM zone. We know that Assam falls in 46 North UTM zone. Okay, and see, it will also highlight the study area. Okay, and click on run. Then close. Your both the layers are reprojected. If you want to see whether it is reprojected or not, right click on it. Okay, then go to properties. Okay, and see, this is your assigned coordinate reference system in source. Okay, here you will find the assigned the assigned coordinate reference system. Okay, so this is your 3264646 north zone. Okay, so we have reprojected our layer from WGS 84 to UTM zone, from geographic coordinate system to our projected coordinate system. Okay, now let's rename these two layers. Okay, and yes, so how can we do that? Right click on it, click on rename layer, and if you want to keep the same name, just copy this. Okay, and this layer, yeah. Okay, right click on it and rename layer and paste the name. Just copy and paste. Okay, need these older layers, so we will remove it. How we can do that? Right click on it, click on remove layer. Okay, click on OK, right click on it, click on remove layer. Okay, so let's see, we have now reprojected layers. Okay, so first a small thing that we have done. Let me keep this state boundary at the base, and this is our administrative boundary, or let's say this is our district boundaries. Okay, within the state. Okay, next I want to add these flood inventory. Okay, this IFI CSV here. Okay, and we will add your CSV. So CSV you cannot drag and drop. Okay, what you have to do, you have to go to your site toolbar, click on this Open Data Source Manager. Okay, this icon here. Okay, and in these options, find out this delimited text. This is the fifth, yeah, this is the sixth option here. Okay, and give a file name, browse to the folder, click on these three dots. Sorry, you have to open this layer. Okay, click on open. See, when you find out the layer, in X field and Y field, we have to provide longitude and latitude. Okay, got it? You have to do all these things. Then click on add and click on close. Okay, you see, this is the GPS location of the flooded regions in India. Now, because we don't want the point data from other parts of the India, we are only interested in the Assam region. So what we will do, we will clip out these point features with these point data. Okay, so how you will do that? You will go to vector. Okay, you will go to geoprocessing, then click on clip. Okay, you are clipping the data. Click on clip. Okay, your input layer will be, of course, your point data which you want to clip out. Okay, and based on the overlay layer, and that you can use any of them because they both have the same extents. Okay, so let's use Assam admin boundary. Okay, so this will be created as temporary layer. You can make it permanent by save to file. Okay, I'll just keep it like this. Then click on run. Okay, close. Okay, if I close this, see, you can see these pink dots. Okay, and let me close and see. So we have clipped out our flooded GPS data, right, only in the Assam region. Okay, so this is how you clip your layers. So let's make it permanent. Right click and go to export, save features as, because this is your this is not your shape file. Okay, this is the CSV file that we clipped out. Okay, so we have to make it a shape file or a geo file. You can go with any of them. Okay, let me go with the shape file now, and let's give it a path. Let's give it a name, Assam floods. Okay, click on save. Geometry will be taken automatically. Otherwise, you can also give it a point. Okay, and let's change our UTM zone to 46 north. Click on OK. Okay, see, we got our projected GPS coordinates. Okay, let's remove what we don't want. Click on right click and remove layer. Click on OK. Okay, I hope everything is clear till this point. Okay, so first two vector processing we learned till here, reprojection of vector layers and clipping of the wanted data. Okay, right. Next, I want to add the hospital layers. Okay, hospitals in Assam. Okay, let's differentiate these two layers. Okay, we will be confused with hospitals and flood layer. So how we will do that? We will change its symbology. Let's remove this. Yeah, we will change its symbology. Okay, how we do that? We click on the first icon in the layers panel. Okay, and go to simple fill. Okay, and when you click on simple fill, you get the options of different icons here. Okay, different symbols. So you can click on any of these. Okay, and if you scroll above, you can increase or decrease the size. Okay, let's also change the color because this is again confusing us. Okay, I will go with let's say yellow. Okay, I think this step is also clear. Now again, let's go to our vector processing. So now I want to know that if this particular location again flooded, location is again flooded, or if this particular district is again flooded in this part, okay, so how many hospitals will be available for me if some tragedy happens, okay, if some fatality happens, if some injury happens to me, okay, so how many hospitals or what hospitals will be available nearby me? So let's say I want to take the radius of 10 kilometer, okay, I want to know within 10-kilometer radius how many hospitals are available for in case of tragedy, okay. So how can I do that? I want to add a, for that I have to add a buffer of 10 kilometer, okay, I have to create a circle of 10 kilometer so that I can get the information on hospitals within 10 kilometers, okay. So how you do that? You click on vector, go to geoprocessing and click on buffer, okay, click on buffer, okay. So of course our input layer will be are Assam floods. Okay, so we want to know in case of the flooded location. Okay, and you see you can change the see, because this is our projected system. So you in place of degrees here you are getting meter, kilometer, feet, miles, and yards. Okay, these units. So click on kilometers because we want to know the distance of 10 kilometers. This is your segment, like how many segment segment of circle you want. Okay, you know segments, what are segments, okay, right, click on run, okay, let's close it, okay, see we created a buffer. Now let's see how many hospitals are available, okay, let's make it. For that, of course, first a task will be to make it transparent. So again go to layer styling panel, okay, and click on simple fill, make sure that particular layer is selected here as well, okay, and in fill color make it transparent, okay, fine. See, if I talk about this location, then only one hospital will be available in the radius of 10 kilometers. This one is little outside, okay, this is little outside, so this is the one hospital. So in the same way you have two hospitals here, okay. Now let's understand, like what is the minimum bounding geometry, okay. So this actually state boundary is not a minimum bounding geometry for these floods or for these hospital point locations, okay. So let's say we want to know the minimum bounding geometry, or it is also called as convex hull. Let's use Assam state boundary. I'll explain why this happened. Click on run. Yes. Okay. See, this convex hull here, the geoprocessing. Okay. This geoprocessing is for your is not for your point features. Okay. If you want to create your convex hulls for the point features, for that you have to use the minimum bounding geometry option. Okay. So this is just for your polygon layers. Okay, so let's make it again transparent. Okay, see, this is the minimum bounding geometry for our state. Okay, so assume that convex hull is like there are some nails sticking out of a wooden board. Like you have put some nails on a wooden board, and then convex hull. This convex hull shape is basically the shape form will be formed when you want to put a tight rubber band surrounding the nails. So you see this gives you the minimum bounding region that you can create around your area of interest. Okay, right. Minimum bounding geometry. Yes. So if you want to try this minimum bounding geometry for your point features, so just type minimum bounding geometry. Okay, scene processing algorithms, you will get this. So I will encourage all of you to try this. Okay, right. So next is, let's see what is our other processing is our difference. Okay, difference. So for that I am going to load one layer which is northeast districts are also marked. District polygons are also present. Okay, let's close what we don't want. Okay, so let me drag this to the bottom. Okay, now as the name suggests, difference will create a layer subtracting your northeastern states, which include Assam as well, okay, from the Assam boundary, okay, Assam state boundary. Okay, so let's try and see it visually what happens. Geoprocessing, let's go to difference. Okay, so input layer will be northeastern, okay, and your admin boundary will be your overlay layer. Okay, you can read about it here. Okay, they have given you some information about it. You can read about it. Click on run and close. Let's say what we have got in difference. If I close this, all these things, see, we have removed the Assam layer from the northeastern boundary layer. Okay, so this is how your difference works, right? So I hope this is clear how it is working, and let's close this again. Okay, now I'll ask all of you to try the intersection, symmetrical difference, union, and eliminate selected polygons, okay, by yourself. So the all the processing that I just explained, these are the opposite of that, okay. So if you will work it by yourself, then it will be quite helpful for you, okay. So now let's move our story ahead, okay. So now I want to count the hospitals. As I said, we want to count the hospitals, not manually, but we want the software to count this for us. Okay. So how we can do that? One thing, you can directly use the processing for buffer polygons. Okay, between buffer and hospital polygons, you can do that. Okay. I mean, this is one of the assignments that you can do. You can use buffer polygon. Okay. Um, now, let me also join the this hospital layer with the polygon layer. Okay. Now we want to create a layer which will have the district information and as well as the hospital information in a single layer. Okay, that will be a single layer. Right now we have these two layers. So how can you join your point features and your polygon features in a one layer? So you can do that by joining it by location. Okay. See, by location means that if you will see that this particular star, this is a point feature. So it has some latitude and longitude, right? So the concept is it has got some latitude and longitude value, and also this polygon feature at this particular point has some latitude and longitude value. Of course, both the values from star and polygon will be same. Okay, and our join by location processing tool will help us in joining these two latitude and longitude. Okay, but this particular star or this particular feature will be contained inside this polygon. Okay, so this is how you are joining the two features by location. Okay, using the latitude and longitude values. Okay, now let's go to join. Okay, just type join in your locator toolbar. Okay, so you have this join attributes by location. Okay, click on this. Okay, so what we are going to do here, we are going to join our features in hospitals in Assam. Okay, by comparing it to our Assam admin boundary. Okay, and we are going to use R within. Okay, not intersect, we are going to use R within. Run, close, and see. Now we have got a joined layer, okay, in which if I go to its attribute table, you will find the hospital information, okay, based on this latitude and longitude, and also your district layer. Okay, so if you will see, the district names are repeating now because these many hospitals, like suppose this 9 hospitals are within the Barpeta district. Okay, and see, these are the hospital names. Okay, these many hospitals are in the Barpeta district. Okay, so I hope little bit is clear that how we are counting our polygons. So let's count the number of hospitals in all districts. Okay, district wise calculation. So this is your Barpeta district because I moved my cursor in the table. Okay, so that's why it is highlighted. If you want to remove this highlighting, then go to this refresh button. Okay, so go to vector, go to analysis, okay, and you have the option of count points in polygon. Okay, count points in polygons. Okay, so which polygon we want? We want Assam admin boundary. Okay, and points from, of course, joint layer. Okay, and you can give it a name like hospital count. Okay, then click on run, close. See, with count, it will provide you a polygon layer. Okay, it will provide you a polygon layer. Let's keep it below our join layer. Okay, so now if what if we want to visualize this, because with the same color you are not able to see any difference. Okay, then what is the benefit of this? So for that, let's start symbolizing it. Click on count, click on this, open the layer styling panel. Okay, and after that give it some symbology. Let's say I want to go with graduated symbology. Okay, and based on my hospital count. Okay, and give it classify. You know how these things are done. Okay, so natural breaks, let's go with natural breaks, and I also want to change the color. Right, so now you can see we have color coded the count of hospitals. Okay, so as you know that this particular district, okay, has 30 to 58 hospitals, right? You can increase the number of classes, right? 30 to 58 hospitals, number of hospitals, 30 to 58. So this is how you use your count layer. And if you go to its attribute table, you see this attribute table option here. Okay, on the top, click on attribute table, then here you get the hospital count. Okay, district wise, right? So yeah, in Barpeta district you have 9 hospitals. Okay, so this is your hospital count. So this can help government if they are planning to work on the medical infrastructure or something like that. District, and whatever processing now we will do, we will use the selected features only option in our dialog box. Okay, now I want to change this polygon because this is a polygon. See, when I am clicking on it, the entire area is highlighted. Okay, I want to change this polygon to polyline. So let's see how we can do that. So click on vector, click on geometry, and you go to polygons to polylines. Okay, see, if when we have selected some feature, so this option is open for us. If you have not selected anything, this option will be deactivated and all the polygons will be converted to polylines or lines. Okay, and yes, we are going to work with now count input layer. Okay, the count one. Okay, then click on selected features only. Okay, so line will be created and click on run, close. Okay, now let's see whether we have created something or not. Okay, let's close other layers. Okay, see, we have created a layer. When I'm clicking on the center, nothing is getting selected or highlighted. Okay, but if I click here, my line is highlighted. Okay, so now why we have done this? Now we want to see that how many highways, because there are so many hospitals here. Okay, in case of tragedy, maybe people from neighboring districts wants to visit these hospitals. Okay, so let's say how much connectivity of roads we have for this district. Okay, so how we can do that? We need our Okay, let's change, make it black or red. Okay, sorry, I'm doing something wrong. Yeah, let's change its color to black, or let's make it a little bit thicker. Okay, yes, now we can differentiate it. Okay, so we have to find out like how many highways from outer district or outer district to this district are intersecting or coming. Okay, this will not give you, the next processing will not give you the data on inside roads or highways, but this will give you the data on the intersection point of, or how many highways are intersecting or coming from the outer neighboring district to the district of our interest. Okay, for this we are going to use line intersection. Okay, again go to vector, go to geometry. Okay, where was it? Yes, in analysis tool. Okay, this is there, line intersections. So click here. So for this it only works with the line line features. Okay, so first layer will be our lines, and next layer will be our Assam. Okay, Assam highway, or let's change the order, intersect with lines. Okay, let's keep it this way. Then click on run, click on close. Okay, our intersections are created. Let me close the joint layer and all these things, and see, you can count these points. Okay, you can count these intersections, and this will give you the idea like how many the hospital counts will be 58, of course, right? But how many point features are there? Okay, you can check this. So these many highways are intersecting, but sometimes the highway is repeating itself, so you have to take care of that thing. Okay, when you are counting it. Okay, so these are the intersection points of the highways, or it also shows that these many highways are, or these many lines are intersecting the other line. Okay, in general. Okay, now, okay, so let's work on the other processing. So which is your line length count. Okay, again go to sorry, yeah, again go to your analysis tool and find out this sum line lengths. Okay, and you can read about it here. Okay, this actually takes a polygon layer and a line layer and measures the total length of the line and the total number of them that crosses each polygon. Okay, right? So for polygon I will go with the count. Okay, we need a polygon, we don't need a line, so that's why I didn't use line there. Okay, and because we have selected our one district, which is our area of interest, so it will always show us the selected features only. Okay, and of course we want to count the highways. Okay, we want to work with the highways, so it will give you the sum of the length of the highways, total sum. Okay, and it will also give you the count. Click on run, click on close. Okay, right, so this created a polygon of for our area of interest. Then again you go to its attribute table. Okay, and if you come here, then you will see this is the total length of the sum of the length of the highways. Okay, or the linear features or the lines which was inside or intersecting the uh, this particular polygon. And okay, and this is the total count, so that's why this number is too big, this big. Okay, this is 526. So there are many like very small lines, but the purpose here is to understand how to count the features or how to count the lines inside a polygon. Okay, if I generalize it. Okay, now I uh, suppose you have, understand how to filter the data. Okay, there are so many hospitals in this area. Okay, or maybe there are different type of hospitals. Some are, some have specialization in cancer surgery, or some are working in heart problems. Okay, there are different type of different hospitals with different specialities. Okay, so if I want to filter it, how can I do that? I will right click on it. Okay, again I'll go to the hospital layer, I'll right click and find out this filter option. Okay, click on filter, right? So this hospital underscore n is your hospital name. Okay, here we do not have specialty data. I mean the data is not present. So we are just using hospital name here. Click on hospital. Suppose you had specialty, then of course you can use that as well, right? Hospital name. So now let's see what all hospital names we have. Okay, so this is your these are the name of different hospitals. Okay, let's say I want to go with BP Civil Hospital. Okay, BP Civil Hospital. I want to see, I want to find out the distance of the city center, okay, or of the flooded layer, let's say, okay, flooded areas from this hospital. I want to see how far these centroids or my flooded locations are from this hospital. In case of emergency, is it possible for me to reach there or not? Okay, so this is our next assignment here. Okay, so hospitals, so what you will do, double click on hospital n or any of the field that you want to go with, click on equals to, and I want BP Civil Hospital. Okay, so double click here, right? And you can test your results. Click on test. So you got only one row because this is your unique name. Then after that, click on OK. Right. So let's find out where that hospital is. Let's zoom in. Okay, let me close other layers. This is confusing now. Yes. See, here is our BP hospital. Okay. Let's just open the state boundary. Okay, so this is our BP hospital, kind of a center in the center, like kind of a present in the center of the state. Okay, so this is, I think this is going to be interesting. Okay, now let's for this, if I want to see the distance of the flooded location from this hospital, for that I have the option of creating a distance matrix. Okay, so go to vector, okay, and go to analysis, okay, and click on the distance matrix. Let me use hospitals here, hospital name, and centroids here, name too. Okay, let's click on run. So let's click on the centroids, and this is our distance matrix. Okay, if I open this window, if I open this, see, this is my BP Civil Hospital. Basically, your 112 kilometers, okay, from North Chachar Hills. Okay, and this is how you get your data in matrix form. Okay, so this gives you the idea of how far this hospital is from different centroids. Okay, this is and now I'll go to research tools. Okay, because I think we are getting little late. We have to finish some more things. Okay, so let's go to research tools and let's create some random points. Okay, so random points in polygons. Let's create some random points in polygons. So you can take any of the polygons here, no foundations. Let's take some admin boundary. And how many points you want to create, I'll tell you the significance of it. Okay, let's create 10 points. Okay, you can also set your, if you want, you can also set the minimum distance between points, but it is optional. So just keep it as it is. Okay, and click on, and here they have given all the description what these things are all about. Okay, click on run, click on close. Okay, see, your 10 points, 10 random points are created. Okay, are created in this, in each polygons. Okay, see how we can extract the layer extent. Okay, so let's go to layer extent. Okay, I'll use the count. Okay, and let's click on run. Yes, see, this has created the extent for us. Let me put it transparent. Okay, so this is your rectangular bounding box for the, for your polygon or for the area of your interest. Okay, so you can use this box as a mask to extract area of interest for your work, then you can use the you can use this extent, extent option as well. So data management tools. Okay, so in data management tool, we are going to learn to merge feature and to split vector layers. Okay, so we have learned this join attribute by location. Okay, and we know how to reproject layer. Okay, so you try this create special index and see what happens. Okay, and here I will demonstrate merge vector layers. Okay, let's see how we can merge. We have learned how to merge raster layer. Now let's see how vector layers can be merged together. Okay. So for this, I will use Assam admin boundary and also northeastern states of India. Okay, and let's see how it works. Click on run, click on close. See, this is just the opposite of the difference, if you will notice. Right? So in difference, we removed the Assam area from the northeastern zone, okay? But with the merged option, we included it, okay? This is how you can merge your two layers, okay? I hope this is clear. Now, next thing, next and the second last thing here is to split vector layer, okay? Let's see how split vector layer works. Okay, so for that I will go with the, let's say, where is northeastern states of India, okay? But see, here you have to tell on which field basis you want to split it. Okay, so name two are unique, okay, or unique. Name one is the name of the states. Okay, so this will give us 7 states, 7 different vector layers. If you will go with this name two, then you have to, then it will split it into the number of features or the number of districts, is this particular layer have. Okay, I hope this is clear. Let's go with the name one. So you can also change the output, file type. Let's keep it GPKG. Otherwise, your 7 to 8 layers will have, shape file will have all the supporting files with it. Okay. So that's why QGIS is intelligent to keep it GPKG by default. Name one, and let's save it to directory. Okay. And let's select the folder. Okay. Make sure that you select the folder. Otherwise, it will send it to your some default folder. Okay, so click on run and see in this folder you got different output of different states. Arunachal, if you will just drag and drop, let's see what happens if we remove all these things, and let me just drag and drop. See, I got the layer of only Arunachal Pradesh with different districts. Okay, in this way I will get the layer of Manipur. Okay, so this way you get different layers of different districts. Okay, now let's see one processing that will help us understand how vector processing and raster processing can be combined together. If you have this data, then just drag and drop water quality data. Okay, so water quality data. So this is the data points, this is the GPS location of all the wells. Okay, wells from where we take water. Okay, or the testing wells by the CGWB, like Central Groundwater Board. Okay, so they have made some calculations on water quality from different parts of India, from different locations of India. Okay, so this is the data from the CGWB. Okay, this is your vector data, right? This is your SHP. Now let's convert this vector into the raster layer. Okay, so how we can do that? We will go to raster. Okay, and we will go to analysis, right? And let's create a grid. We know the raster data is in grid format. So these are different type of methods, different type of interpolation. Okay, you can check in which type your data works. But I'll go with inverse distance to power. Okay, so with inverse distance to power, it means that your data, suppose you collected data at let's say this point. Okay, Z value, okay, based on which gridding will happen, okay. So let's say I want to see the electrical conductivity here. I want to see the changes in electrical conductivity, okay. So and let's create the float data, okay. Float data means it will also include your decimal points, okay, and you can give it a some output location here, then click on run. Yes, okay, see, we created the grid, you can see. So you know how to decorate your rasters now, okay, and for that again you click on this first first option here, and let's give it a simple color, okay. Yes, let's give it a single band pseudo color. Okay, and you know that we don't want extra layers. So for this we compute our histogram. Okay, and we remove